The cycle time on an assembly line is the budget of time that each workstation has to do whatever it is that it's assigned to it each time it works on a unit. Now, this particular problem is describing what needs to be done along an assembly line. A production line is to be designed to assemble a product. The assembly of this product requires 3 tasks, so these are what will be assigned to the workstations. One of which requires 0.3 minutes to complete, one of which requires 0.4 minutes to complete, and one of which requires 0.7 minutes to complete. Now, what's the question? What is the minimum possible cycle time? That's a principle, really, not so much a formula. The minimum possible cycle time, CT for cycle time, is the length of the longest task. You say, all right, well, we were told about 3 tasks on this particular assembly line. Which one's the longest? 0.3, 1.4, 0.7, 1.4. The answer to the question becomes that largest number, 1.4, 1.4 minutes. Now, to remember this, I think it's easiest to just picture it. Why is that true? Remember that the cycle time is the budget of time that each workstation has. Okay, if you cut that budget down to anything less than 1.4 minutes, whoever is assigned to do that one task that takes 1.4 minutes would never have enough time to finish their work. So it wouldn't work. That's why you can cut that budget of time down to 1.4 minutes, but you can't cut it any further, and it becomes the minimum possible cycle time. Now, the next question appears to be discussing the same prospective assembly line, because a production line is being designed to assemble a product. These do appear to be the same 3 tasks. One's 0.3 minutes, one's 1.4 minutes, and one takes 0.7 minutes to complete. Now, what's the question? Oh, there's more information. If the production line has 3 workstations and the cycle time is 1.5 minutes, which is longer than 1.4, that would work. What's its efficiency? Oh, all right, now that really is a formula. If you're talking about an assembly line, the fastest way to calculate its so-called efficiency is to take the sum of all the tasks times and divide it by n, the number of workstations, times CT, the cycle time of that line. Okay, so this sigma for, sum of, add up, T, means add up all the task times. This in the numerator. So this is where we would add up 0.3, 1.4, and 0.7. So that adds up to 2.4 minutes. Okay, that's the numerator. And actually, before we go any further, that 2.4 minutes has an interesting meaning in and of itself. 2.4 minutes is however long it would take you to assemble one of this product all by yourself. If you're working all by yourself, you'd have to do all 3 tasks. It would take you 2.4 minutes to make one of whatever these things are. Now anyway, we're looking for the efficiency of the line that's dedicated to doing this. N is the number of workstations, and we were told, there it is, N equals 3. So that would go there. And CT is the cycle time, and we were told that. They had chosen a cycle time of 1.5. So that goes there. So if you say 2.14 divided by 3 times 1.5, you get 0.5333 some odd, or basically, we like to talk about this as percentages, 53%. That's the answer to the question. Oh, if it had 3 workstations and you're running with a cycle time of 1.5 minutes, that particular line is 53% efficient.